Ever wondered why some questions feel off? Like, how do betta fish survive without oxygen? Or why can't we vote online? These might sound like smart questions, but they're built on hidden flaws, assumptions that aren't true to begin with. Today, we're exploring how researchers are teaching AI to spot these tricky errors, and why it's a game changer for how we think about information. Let's start with the basics. A false assumption is like a hidden belief that makes a question or claim unreliable. Take the betta fish example. The question assumes fish can live without oxygen, which is wrong. Betta fish actually need oxygen, just like us. But how do you teach an AI to catch these mistakes? The researchers had a clever idea. They trained AI to question the question. Here's how it works. The AI starts by searching the web, think Google or Wikipedia, for information related to the question. Then it uses a tool called INSTRUCTOR to sort through the most relevant facts, like a detective piecing together clues. Next, it breaks the question into tiny parts, called atomic assumptions. For instance, the question, why does a bad throat turn into a cold? Assumes that throat pain directly causes colds. But science shows colds are caused by viruses, not sore throats. Let's unpack this. When an AI encounters a query, it doesn't just spit out an answer. Instead, it deconstructs the question into its core components. Take the classic example, why do we need sleep? The assumption here is that sleep is purely for rest. But research shows it's also critical for memory consolidation and cellular repair. By isolating these assumptions, the AI can verify each one against factual data, like scientific studies or databases, rather than relying on patterns in training data. The team tested this approach with big names like GPT-4, Llama, and Mistral. Guess what? GPT-4 caught false assumptions 98% of the time, super accurate. But even smaller models like Mistral 7B did pretty well, proving this tech is becoming more accessible to everyone. Why does this matter? Imagine AI helping students spot biased arguments in homework or journalists fact-checking claims before publishing. It's not just about correcting facts, it's about teaching people to think critically. The study also found that adding more evidence, like multiple Wikipedia sources, made the AI smarter. More data equals better insights. But here's the catch, AI isn't perfect. Sometimes it misses the mark, or even adds new false facts. For example, one model claimed horses were never used for glue, but history shows they were. This highlights a key challenge, teaching machines to distinguish nuanced truths from oversimplified answers. Let's circle back to the original problem, hallucinations. Large language models, LLMs like ChatGPT or GPT-4 are amazing at generating answers, but they can hallucinate, make up information they're not sure about. Imagine asking, which countries border Kansas? The real answer. None. Kansas is a US state, not a country. But an AI might spew a list of nations, convinced it's right. Why? Because it's assuming Kansas has international borders. So how do we fix this? The answer lies in questioning the question. Researchers discovered that traditional fact-checking isn't enough. A false assumption isn't a wrong fact, it's a wrong idea underlying the question. Like asking, why do bald people grow beards? The assumption here is that head hair and facial hair are the same. They're not. The problem isn't the facts, it's the premise. Their solution. A two-step process. First, they turn questions into statements. Why can bald people grow beards? Becomes bald people can still grow beards. Then they check those statements against real-world evidence, like scientific articles or databases. But here's the clever part. They break the question into atomic assumptions, tiny, testable pieces. For the beard question, that means checking if head hair and facial hair are the same is true. Spoiler, it's not. Think of it like a detective. Instead of guessing the answer, the AI investigates each part of the question. If the evidence shows the assumption is wrong, it flags it. This isn't just about correcting answers, it's about making the reasoning visible. You can see why the answer is what it is. The experiments. Wildly promising. When they tested this approach on 5 LLMs, adding external evidence cut down hallucinations. But the real win was the atomic assumptions. It wasn't just accurate, it gave clear, human-friendly explanations. Like the 2020 Olympics wasn't in 2020, but it still happened. Why does this matter? As AI becomes more part of our lives, we need systems that don't just give answers but explain their reasoning. This research is a step towards smarter, more transparent AI, where machines don't just speak but think clearly. Thanks for watching. If you want to explore how AI learns to think critically, hit subscribe. And let me know in the comments, what's a question you've heard that probably has a false assumption? Let's chat.